Alright, this video is going to be a fun one. This is for the input system and the collision system. So in front of us we have the class diagram for the input system, which consists of a keyboard event manager, the single key event manager, and the inputable. Inputables have key pressed, key released, which are callback functions from the system that receive information about pressed keys and released keys. We have the registration process, which follows the command pattern. It starts with the submits, ends with the scene registration and deregistration, a delete reference for constant removal from the manager, and a setter for the delete reference. And then, very similarly to the alarmables, we have a structure that has information about delete references, more delete references, specific registration commands, and specific registration states for each key to be registered, because there's a variable number of keys per object that will be registered to the system, and so this map can grow or shrink to allow for that many, or however a variable number of registrations. On the manager side, the scene has a multi-ton instance of the keyboard event manager, which has a map of keys that it is currently tracking based on what inputables want what information about what keys. We have the register and deregister methods for this manager, and the process key events. The keyboard manager has a variable number of single key event managers, which are responsible for monitoring individual keys and relaying information back about the one key that it is assigned to, this key. It has two collections, one for inputables that want information about a key press, and a set of inputables who want information about a key release, and then the state of the current key. The register and deregister go all the way into the single key event manager. And there's also an isEmpty function for when no inputables want information about a specific key. The single key event manager can be shut down because it is no longer needed. So if we jump into, let's start with the inputable, which is down here. This is the header file. I will scroll through it. So again, we have that structure down here with information about specific keys in it, about each specific registration that an inputable might want to know about, and we store those in a map with a key event pair as the key, and then a input data structure within that. Registrations care about a specific key and the input event type, so that is released or pressed, and that's what the information that the inputable wants to know about. So up here in this example that I'll show in the documentation later as well, it's probably better in the register one. This is actually a documentation about the key press. So when you register for your key registration, you'll have, if you care about both pressed and released, you'll have to register for both of those separately. And these are the overridable functions that return information about pressed keys and released keys. Here we have the CPP, which has much of the same registration code, including the delete references, which are important. And then if we jump into we also have an attorney for this class, as well as, I didn't mention it, but for the drawable has its whole attorney. The alarmable has its own attorney. The updatable has its own attorney. There's attorneys for everything. But back to the inputables, let's go to the manager. So the two levels that we have are the keyboard event manager, which manages all of the inputable objects in a given scene, as well as all of the single key event managers happening at the same time. And we have a map of those to store the key. We have a map of the single key event managers, which in turn store all of the necessary inputables. So when a registration or a deregistration comes in, the keyboard event manager shuffles the registrations and deregistrations into the appropriate keys event manager. So we go into that. It's a very simple class, not a lot going on here. We iterate through all of the single key event managers and have them process their own key events, and then those in turn relay back to the inputables the necessary information. And so if we jump into those, here's the header for that. Single key event manager, all the things that we saw before. And this class is bigger than the more general manager, because this one has to do with all of the relaying information and specific registrations. So this is this, and let's see, where's process? Key events. Process key events. It does a state test and then processes. If there was a state change, we then process the released or pressed, and relay the information to all of those inputables that want to know about it. So that is, I believe, class diagram, data structure, yes. Manager and exable, yes. Registration and deregistration. Operations from both layers, we did that. Command pattern, we for the duplication, we have the individual states inside the inputable, which doesn't allow for duplicates or re-registrations or re-deregistrations. Runtime cost, we have constant deletes, and actually not prepared. Once we get all the way down into the register, we put them right into the back, so that we we insert right into the end. So that should be constant, I believe, unless I'm gravely mistaken, because we're putting it right at the end. We get the iterator to the end, and then we insert it there. So unless it's iterating through the whole list, which I don't believe it is, this should be as low as it can be. Process keyboard events efficiently. Yes, it processes the keys once per manager, and then relays to all the updatable, or to all the inputable objects. If something has been done, the test is only done once for everything registered. And then the destructor, especially for the inputables, again, is the virtual, so it's going to be called correctly. And if it was in this build, we would see the output from that destructor that is just tracing that for me. So that is the inputable. Let's jump into everyone's favorite, the collision. So here we have a monster, a kind of monster of a class diagram. If we start with, let us start, this is, okay, I believe this is a very similar one to the weak, this This is the Sprint 6 one, so this is the second week that we did collision, I believe. No, this is the first week. Yes. So let's just start with the commands. So we have two different command bases. We have the collision command base and the scene registration command base. These down here are templates, and they just do their basic registration for a collision a collidable object instance. So these have pointers to the collidable in question, and those are done on a per object basis. These ones up here are scene level commands. There's the collision command base, and for these we have the test pair command and the test self command, which create the collidable groups necessary. And then we also have the collidable group which takes care of cleaning up collidable groups. Here we have the collidable group, the template class for that. There's a collection of collidables registered to that group. It can be deleted as its registers, and it can return the collection. Here in the collidable, right now we only have we have the collidable model, and we have right now just the bounding sphere. We have the collision callback from the whole system, two template classes for the registration, accessor for the B sphere, collidable model, and then the update collision data. And then the scene has a multi-ton collision manager, which keeps track of the test commands and the delete commands for the collidable groups, and then has all of these for registering and processing collision stuff. So let's jump into the collidable. We have virtual destructor, which is important. A base collision call that we never see because the derivations of collidable override this, so we never see it. We have template collision registration, which has to be called a certain way by each collidable because it has to pass its own type. Set collider model, all these very important. That's the header. And then this is the very short CPP file. Here it is. If we jump into the collision manager, let's do the collidable group first. I don't even know where my collision is. Here it is. She's got his own folder. We have this monster template class, which is a collection of all when it is filled out. When an actual instance of a collidable group is created and all the types are filled in, a collidable group tracks the collection of instances of the same types of collidable objects to be compared to other collidable groups of their own type for collision processing. So we have where's my collection? Here he is. We have a collection of a list of type C pointer. And we've chosen a list here because we don't care about the order of them, we don't care about mapping them, we just need a list of them, and the collidables have their own information. Other than that, this is a very straightforward class, like the other registration type managers that we've seen, except this one is templatized for colliding whatever kind of stuff you might want. Jump into the collision manager. This is not a template class, but it does have template functions. these create the collision test commands, which in turn create the collidable groups. Jump to the commands here. Yes. Nope. This is the wrong one. Unless I'm crazy. I've lost it all. I'm so sorry. Here we go. Collision test self command. Yes. I was right. So these create these access the proper collidable groups is what I meant. They don't create them, they're singletons. So when they are accessed, that's when they pop into existence. But these commands are what run over and over again in the scene that process the collision testing. So in this command, we have collision against self, and this one we have collision against two collidable groups, as well as the actual collision test itself, and the visualizer stuff is in here too. And then just quickly for the collidable group deletes, when a collidable group is created, it sends a command to the collidable manager, which has this execute that deletes a collidable group of type C, and during cleanup of the collidable manager at the end of the scene, the collision manager, so sorry, where is it? This delete collidable groups is called, and all the collidable groups are deleted. And that happens between scene changes and at the end of the game. Okay, let me check the checklist. Collision group and associated exables. Necessary commands, yes. Full header file, yes. Class diagram, yes. Data structures, believe I went over. We had the list of collidables, which are in the collidable groups, and we have a few command patterns flying around here. Registration is done with the command pattern. For the duplication, we have, again, the registration states. We see them. Where are they? Registration command. Why can't I find it? There should be that in here. I'm going to come back to it because I don't want to scrap this video. When we process the collision test, sorry, that threw me for a loop. I'm going to have to find that, maybe show it in a different video. When we process our collision tests, we go through all of the collision test commands and we execute those, which does all of the testing that we see here, and returns back to the collidables when the test results are true. The self-test here has the efficient self-test that we talked in class, as does the test pair. We saw the delete, we saw the documentation, and then all that is set up on a per scene basis. The scenes have the setup for, wow, I have so many folders open. The scenes have the setup for the collision stuff that starts the collision self and the collision pair going. That is all for this video, and will make sure that I find that missing collision thing and just put it at the top of the next one. Thank you.